So till now we have seen some of the core activities of the pipeline. What are those? Copy activity as initial step. Get metadata. Filter activity. The for each activity. If condition activity. The last example what we have seen with the conditional activity. And lookup. Of course, before that we have seen about wait activity. What is the purpose of wait activity? There are two advantages. During pipeline execution, some activities are expecting some acknowledgement from the other systems. At the time, the process may be delayed. Without getting that acknowledgement, if next activity starts executing, there is high chance of failure of that pipeline. That's why between activities, okay, whenever a particular activity is expecting something from some acknowledgement from the other systems, then involve wait activity. That is advantage number one. And second thing is you want to test whether your logic is perfectly working or not. Suppose if condition you are configuring, whether this condition is becoming true or false, you want to validate the condition. In that case, just to test that condition, wait 1 you will give under true part. Wait 2 you will give under false part. Okay. So if you feel that condition is validating perfectly, then you can configure, later you can configure perfect actual activity, which is needed to you. And finally, we have seen about some lookup activity. What is the advantage of lookup activity when compared with previous? So that is also similar to the copy. But copy is reading, get metadata. Get metadata is reading file metadata, but not data within that file. But lookup activity can read data from a file. Okay. So after that, more we can see about the lookup in coming data flow transformations. Okay. Here for the lookup activity, there are some limitations. Limitations of lookup activity. Any search is done. Remember two things: 5000, 4 MB, 24 hours. These are the three limitations. That means the lookup activity can read only 5000 rows. Up to, not only, better word is up to 5000 rows. That means only for small volumes of data only that you can use it. Even if you take any small organization, the data will be 10,000 rows, 1 lakh rows, like that. Okay, that's why every time lookup activity cannot work. All these are the some technical limitations in the version 1. That's why in version 2 you have data flows. Within the data flows, you can, whatever the data volume may be, you can transport. Okay, and second limitation is volume. Data volume max limit 4 MB of data. Okay. Third limitation. Runtime execution timeout. Is 24 hours max. You can say this one as max limit. Suppose if your pipeline exceeds, if the particular activity execution exceeds more than 24 hours, automatically the pipeline will be automatically discarded. Timeout limitation. So these are the important points that you need to remember for interview or certification. Okay, that means the lookup is fit up to only for small, very small volumes, not small volume, very small volumes. Max limit of volume point of view, max limit 4 MB. Even though data is within like limits of 4 MB, if number of records are 6,000, again will be failed. Of course, if data volume is 4 MB, limits of 4 MB, but number of records are 6,000, but it reads only first 5,000 only. Their failure will not happen. But if data volume crosses 4 MB, failure will happen. Understand? That's why directly don't read data. Suppose I want to read data from a file, a physical file. My file is some GBs of data, not MBs of data. GBs of data, millions of records are there. I want to read and I want to perform some transformations. And then finally, I want to write into some target database, Cosmos DB or SQL. In this case, what is our best methodology? Apply copy activity. Keep the data into data lake. Once data came into the data lake, apply data flows. Okay, within the data flows, again, you have different transformations. By using those transformations, process the data and finally write into our targets. Okay, so remember, these are the three limitations of lookup transformation. Sorry, it's not lookup transformation, it's lookup activity. But again, within this, what you call in data flows, we have again lookup will be there. That lookup is a transformation. This lookup is activity. Two lookups will be there in ADF. Okay. So now, so about remaining activities, these are the regular used activities in the core side, which is ADF version 1. Now come to the version 2 features. In ADF version 2, you have two features additionally. One is data flows. Second thing is Power Query, recently added Power Query. Maybe in future, they may add few more features within this. Now, first we will say about the data flows. In high level, data flow is a activity, is one of activity. Okay. Within data flows, transformations will be there. Transformations. Every transformation is doing some activity. That means some operation on the data. Okay. Each transformation performs some operation on data. So generally, what are the data operations? First, very source of core activities: reading, filter, sort, aggregating. These are all these things. Even joining, merging of the data sets. Understand? All these things. So these are the operations what you are going to perform in data flows. Till now, you have worked with many of the pipelines. At least some 10 or more pipeline examples we have seen. But you did not read the data. You just applied a copy. Of course, with data metadata, you applied, you worked with multiple files. And after that, by using filters or by using if-else, you are routing some files into some target and some other files into other different target. But you did not work with the data. You work with the file, but you did not work with the data. But using data flows, you can work with the data. This is the core thing about data flows in a high level. But what are the additional features? Because these data flows are now available not only in ADF, nowadays available in almost all ETL tools. What is the difference between other data flows and our ADF data flows? Code free, that depends on, that is power of tool, that's it. If you want to say something as code free, of course, you take Snowflake, we perform all these activities, but by writing a code. But in informatics, of course, 80% without code. Maybe for some specialized customizations, you need to write some 20% of the code like this. Whether you write code or whether you are using only the drag and drop kind of features, that is just operating level. Internal level is data flows. Main feature here, data flows will be converted into Databricks jobs. What is Databricks? So these flows at the time of creating data flows, there will be no job. Runtime. When you execute a data flow, runtime, these data flows will be converted as Spark jobs, Databricks jobs. Spark is super speed execution. Okay, like this. So this is one of the major feature. So a simple comment about the Databricks, especially for the new joinings. Databricks is a Spark fast. Okay. So finally, Spark jobs will be executed. The main feature of the Spark is in-memory computing. To perform this in-memory computing in a massive parallel way, you need a cluster. The cluster is provisioned by Databricks. Same Databricks in Azure platform, that is Azure Databricks. What is the difference between general Databricks and Azure Databricks? What is the basic difference? Databricks is at a core level. That means it uses DBFS file system. But Azure Databricks, it can integrate with Azure Data Lake files, Azure SQL files, Azure Cosmos DB files, anything. That means Azure Databricks is compatible with all data storages of Azure platform. Got it? Same Databricks is available for AWS. That is called AWS Databricks. Understood? Okay. Now, in a high level, what are the major important things within the data flows we will discuss today? And tomorrow we go for practical part of it. In data flows, what will be there? Transformations. These transformations, important transformations, source, sink. Source separate transformation, sink separate transformation. Okay, come back to one thing, sir. Come back to copy activity. Can you perform transformations by using copy activity? Can you perform transformations by using copy activity? Because in the case of copy activity, you have to keep two data sets. Source, sink. Without configuration of these two things, your copy activity is not complete. Just reading from one point and writing into other point. But between reading and writing, there is no transformation here. Suppose, let's talk about data flows, especially source and sink. You can guess what it is. If I apply a source transformation, it is reading data. After that, I am applying filter. Understand? After that, I am adding a new field. I'm adding a new field. Let's say new field. After that, I am performing some aggregation. After that, I am applying sink. What is happening? Between source and sink, many operations are there, right? That's why you could able to perform the transformations. Got it. But in the case of version 1, how they will be doing all these things? They have to involve that lookup activities. Because you want to touch the data means you have to apply lookup. Understand? But lookup limitations already have seen. If data volume is more than 4 MB, it cannot read the data. Or number of rows are more than 5,000, it cannot read it. If session timeout is more than 24 hours, pipeline execution failed. For biggest pipelines, which are working with big volumes of data, they may go beyond 24 hours also sometime. Understand? That's why no need to use the previous core activities. In the previous core activities, only one thing is very important: for each filter and get metadata and copy. Of course, weight is also important for. Got it? So between source and why they have given source as separate, sink as separate means between source and sink you can perform other transformations. Got it? So here, like this, other things are there. We will talk about each and every one. I have union transformation, and I have exists transformation, and I have select transformation. Okay. I have generate new field transformation. That means generate new column. That is called derived column here. The official name is derived. Okay. In this way, like you have aggregation transformation, joint transformation. In this way, many. What generally in SQL, how you process data by using SQL with SQL queries. Without writing those things, you can perform all these things. Okay. So here simply the source to read data from Azure, non-Azure data storage. So how to use non-Azure data storage? Integration runtime, self-hosted integration runtime. But that is not good practice. Read data from Azure storage is faster. That's why first I do with copy activity, I read data from outer environment to and write into data lake. Once data came to the data lake, I will apply all these transformations. Understood? So this is just to read data or to configure Azure storage. So what are the supportable storages? Data lake Gen 1. Of course, Gen 2. And blob storage by default. Azure SQL database. Synapse. Very soon we are going to enter into Synapse. Get ready for that. Azure Synapse. Sorry. Azure Cosmos. And non-Azure sources with help of self-hosted integration runtimes. But remember, this is not recommended. Okay, that's why the solution here. Number one, use copy activity for non-Azure to Azure data lake. Then next, apply data flow transformation. In the data flow transformation, your first transformation is source transformation. What sources are supported means these are the sources that are supportable. Understand? Next, if you talk about sync, to write data outputs into target storage systems. What the things it is supporting is all. It is supporting all, but still not recommended. That is not recommended. Now, what is the solution then? I'm extending this solution. Use copy activity for reading data from non-Azure to data lake. Apply transformations. Okay. Number 3, make the sync as data lake. Final output right into data lake only. Then 4, use copy activity again, because already data is in data lake. Okay. So for the copy activity, make your output as input. Got it. Use copy activity for data lake to non-Azure storages. So such kind of techniques you need to follow. So all these are the techniques, not for the small volumes, for big volumes. Definitely you are going to deal data with for big organizations more than terabytes. Got it. At the time you have to follow like these kind of guidelines. Remember, these are not rules, these are only guidelines. These guidelines are given by Microsoft. Got it? Okay. So that is your second transformation. First transformation source, second transformation is sync. Okay. About remaining transformation one by one, daily 1 or 2 transformations we will be discussing and we will be executing. Now, let's see a small practical demo of it. Prashant, you said something no for which question? You just replied as no. For what question that is answer? Already unmuted.
Okay, sir, just wanted to know like why non-Azure transformations, like it is not recommended. Like, is there any limitations we have?
So it's not about limitations. Whenever you are going to interact with the data lake or like Azure storages to non-Azure storages, the writing or exporting data will be slower. Okay.
Okay.
So that's why that's why if you use directly the core activity of the copy, okay, simply without any disturbance, the data will be loaded with some better speed. So still some cases, still you are not satisfied with that copy activity at that time, pure Databricks job that you have to write. Because while writing your customized PySpark code in the Databricks, you can customize how many number of parallel processes that you want. Okay. So one of the scenario about our question, same thing. One of you used to one of our student working with ADF. Their copy activity actually input is 80 million records. Mostly nearly data volume, not more than terabyte. It's near to the terabyte. Of course, we don't know what exactly the length of each record. Based on that, the volume can be fixed. For exporting this into Azure SQL, okay, the time taken is 4.5 hours. This much of time it is taken. Got it. After that, they tested with the Databricks, the solution. That to the customized PySpark coding for reading the data. Because at the time of reading, a number of parallel pieces that you can configure. Okay. Less than 30 minutes, the time is happened. Where is 4.5 hours? Where is 30 minutes? That too, this is the operation only for data loading only. Got it. Suppose if I use directly data flows, I cannot configure how many number of nodes that I need for the parallel process. I cannot configure. When you run your data flow, automatically Azure is provisioning you some size of the cluster. Which one? Yes, we can configure. Yeah. See, not for the transformation, not for the data flow transformations. While executing your core Databricks jobs, Azure core Databricks jobs, that you can configure. Integration runtime, that concept is different. Integration runtime is just a mediator between Azure and non-Azures, cloud and non-clouds.
It also provides compute infrastructure.
But,
It also
provides compute infrastructure. Provides compute infrastructure, but there is no, Databricks cluster will not be executed on top of the integration runtime. Databricks cluster will be executed once data came into your cloud platform. Meanwhile, what integration runtime is helping you is just mediating. Just mediating from non-Azure to Azure. That means on-premise to cloud, or cloud, one cloud to other cloud, such kind of things. Okay. Okay. Let me go. Yeah. Pardon?
In these two scenarios, what is the cost incurred in Databricks?
Databricks definitely cost is high. It depends on number of nodes that you are using for your processes. Okay. Suppose still with the 30 minutes also you are not satisfied, increase more parallelism. At the time, cost will be applied again because more nodes are participating in the execution like that. Nowadays, being a small organizations, definitely they have to worry about this cost. But this cost is cheaper than on-premise data processes. Understand the point, sir? When you compare with these processes running under on-premise, when compared with that cost, this cost is very cheap. Okay. One practical part we will see just how to configure your data flows. Where we are, 1 minute. I forget, system got changed. I forget. User ID password. All of you 1 minute hold, sir. I'm checking my user ID password.
For creating different accounts, can you use the same credit card or is it different required?
Different for once this part is completed, go with the new credit.
New credit card.
Or else migrate into the upgrade into the pay as you go. But don't do that one. One minute, sir, all of you. So online team, all of you created your accounts and started working?
Yes, sir.
Yes, sir. One minute. Verification code not yet received. Not yet received. Okay, sir. We'll see this execution tomorrow class. Now, what are all the other transformations that we have here? We just discussed. Now, only about in a high level, we have discussed about source and sink. But remember, between source and sink, there should be mapping, column mapping. Okay. So while configuring these two things, we have to optionally configure mapping fields. Of course, there is a feature called auto mapping, sir. That's why I said auto optionally. There is a feature called auto mapping. But what is the problem with auto mapping is, for example, I have a file, the file one. In the file one, the first line is header, ID, name, salary, and then the second onwards data. Okay, I want to make this as a data set, or later I will create this data set as, let's say, source transformation. Okay, and come to the sink. But my sink is table, Azure SQL table. This is my sink. Suppose I have table tab 1. The fields are here with employee code, employee name, and income. Now, if auto mapping is by default, auto mapping is enabled. Sir. Suppose in this case, what will happen? If it is like this, always auto mapping tries to do ID with ID, but there is no ID here. Got it? And name to name, but there is no name here. E-name is there. Here salary and here income. The mapping will not happen. Okay, this is one case. In some cases, in the input file, I have only three fields, but in the output table, I have 4 tables. That means 4 columns. Okay. On that way, there might be some schema difference. Schema difference might be there. So that definitely you have to do mapping. At the time of configuring the sink, you have to apply mapping. Which column of sink to be mapped. You have to configure that one. Got it? See, while configuring source, you need not to specify any mapping. But while configuring sink, you have to specify this mapping with source. Okay. So unfortunately, I did not receive that verification code from the Microsoft, maybe from my side. some issue. And tomorrow we will see about that one. Okay, what are all the other activities that we have here? There is select transformation. And there is derived column transformation. And there is filter transformation. I think the filter name is where? There is lookup transformation. Previously you have lookup, sir, but that lookup was activity. This lookup is transformation. And you have join transformation. Generally in joins, you have different types of joins. Inner join, outer joins. If it is outer join, again, left outer, right outer, full outer. Okay, self joins. All the kinds of joins are available over here. But you need not write any query. Everything is drag and drop only. You need to choose what is left side table, what is the right side table, what type of join that you want to apply. Okay, and what will be the joining column. Okay, all these things you have to configure. And next, you have union transformation. Again, if it is union, you have two things: union and union all in SQL. But it's not onion, it's union. Union all. Okay. Of course, you cannot directly apply union or union all. It will ask you one enable one box, check box. Duplicates without duplicates. What is the difference between union and union all? Union all is allowing duplicates. Union, it eliminates duplicates. Okay. So while merging two separate data sets, suppose employee branch 1, employee branch 2, employee branch 3. There are three employees, there are three branches of employees in a separate files. What I want to do is I want to merge all the files and I want to keep into one single table or into one single file. So at the time you have to apply union. Whether duplicates are required, union all. Duplicates not required, union. Got it? Yeah. And one more thing here, exists. This is another useful transformation. This is also. Even in SQL also you have exists. Exists, not exists, like this. Suppose you know that set theory, unions, intersection, to work with such kind of operations. Just a minute, I will show you. Suppose I have a table or data set 1 and data set 2. Sorry. This is my second data set. The first data set has 100 records. Second data set has, let's say, 120 records. Here I have 100 records. And here I have 120 records. But in both, the common number of records are 40 in both the files. Okay. Now only the common records that I want to fetch. Except common exclusively for data set number 1 I want. Exclusively for data set number 2 I want. If total number of records are 120, how many records are exclusive for data set 2? 80. That means the records only available in data set 2, not available in 1. Got it? Such kind of things that I want to fetch. Understand? For example, the real-time use case of it one, especially in my case, day number 1, this is attendance. Day number 1 attendance. Day number 2 attendance. And day number 3 attendance. What I can understand from this? So day number 1, okay, forget about last box, last circle. In what way that I can apply my analytics? Day number 1, 10 people attended. Day number 2, again 10 people attended, but 2 people missed from yesterday. 2 people are new joinings. Now, now I am interested who attended only today. I want. At the time, exists, not exists, there are 2 options. By using those options, you can take help of them. Got it. So who are the generally in customer centric analytics, which customers are more regular, I want to identify. Understand which customers are more regular. There are some customers are very occasional, some customers are very regular. I want to suppose last month data set, this month data set I have taken. Which customers only entered in the current month? Which customers entered last month and who did not enter this month? I want to verify such kind of things. At the time you have to use exists, non-exists. In this way, many transformations without writing any code, you can perform all your complex data transformations. Got it? Still, you have looping transformations. Understand? So all these things like tomorrow onwards, we will see, we'll start working with this coming week. We will spend with only data flows. Once data flows completed, then we go to the Power Query. Okay. Meanwhile, parallelly, I will start one special session, sir. That is Synapse. Let ADF go as in this time, and after 1 week, I will tell you the timing. So mostly 7:30 to 8:30 we are going, and I'm planning to take only Synapse session 8:30 to 9:30. So already I have another batch by 9:30. That batch people, you batch people is 7:30 batch people. If time possible and favors to you, attend 8:30 to 9:30 for Synapse. Okay. So that parallelly we will proceed with that both ADF and Synapse. Okay, sir, all of you. Let's see in tomorrow's session by 7:30. I will log in the class. And one more thing, any pending recordings from my side? Already all shared. Please check what is the last record number. 15. That means the date I want. Date, last class date. 18, today 20. Yes, that means all are completed. Okay, totally 15 sessions are there. But in one link, you will get 2 recorded sessions. Keep it in a separate folder, sir. Those are 2 recordings. Okay, sir, all of you. Let's meet tomorrow. Right, Anil, Lakshmi Narayana, Narendra, Prashant, Vikram Kumar, and Kavita. Tomorrow 7:30 I will log in, sir.